Hello, I'm Zach, and in this presentation I will be explaining to you about network automation. The traditional way to manage network devices was one device at a time via the CLI. Okay, normally you SSH to the command line and you would apply the configuration. Another common thing is usually you would copy a bunch of configuration from the from a text file, for example, and you would paste it into the command line. Okay, so that is how you would have to do it, one device at a time. There were even some GUI tools that you could manage one device at a time, but they also were proven to be slow and inefficient. Okay, so of course, with the traditional methods, one device at a time, it's not really easy to apply global configuration quickly because it's time consuming. It's not standardized, the configuration. There's little version control, okay, as far as the coding as far as the configuration is concerned, and the chances of human error are high because if you send network administrators to go to configure each device, there is a chance that the actual configuration will not be the exact same from one device to another, because we have to remember that there are so many different, maybe thousands or tens of thousands, depending on the the enterprise of network devices that may be in use, or a data center, for example. Okay, so automation and network automation has many benefits. It addresses those issues because network automations allows us to reduce human error. Okay, it makes the time for the changes and the configuration to be applied to be reduced massively. Okay, so there's many benefits to it. How we achieve network automation is by using various different tools. We have our configuration management tools like Ansible, Chef, Puppet, okay, among many others. We have our SDN, we have DNA Center, okay, these especially DNA Center, you have a GUI that you can use. Um, you have SDN, which essentially is decoupling uh, the control plane and the data plane. So you just leave the data plane on the network devices, and you leave the control plane on the SDN controller. Okay, and usually you have the GUI or other forms of automation in the application layer, whereby they interact using APIs. So you have the northbound API that interacts between the application layer and the SDN controller, and then you have the southbound API which interacts between the SDN controller and the network devices. Okay, the network devices only have the data plane. The method of network automation that I would like to discuss further is Python. Okay, so before I move on to Python, the key word I wanted to leave with you is orchestration, meaning automated configuration, management, and coordination of computer systems, applications, and services. Okay, so it's a holistic approach where everything comes under one umbrella and the changes happen immediately across all of the computer systems, applications, and services. So to talk about Python, it's a very fast-growing and popular programming language. It's used across many different disciplines: software engineering, mathematics, accounting, okay, you name it, data analysis. And for network engineers, it's very useful as well. Okay, it's easy to learn, it's human readable, you can even install it on an operating system, and there are numerous network automation code samples for network automation available online. Okay, so it's very convenient for network engineers. Okay, it's a multi-purpose language, and if you think about it, using Python scripts can make things much easier, especially if you're in a medium or large network. Okay, in a small network, you may not need this at all. You may not need scripting, but in most cases, enterprises have a medium to large network. So this is very handy because it can help to configure repetitive tasks, okay, to reduce overhead, administration overhead, okay. It can help with troubleshooting. It can help monitor interfaces, for example, okay. So in case there are um, issues with interfaces, you could potentially have a script ready to deal with those issues. Okay, so that's troubleshooting and monitoring. Okay, so Python is very, very useful. It helps, as I said before, achieve um, the reduction of time it takes to perform changes. Okay, so for example, if you use the traditional method of using the CLI on one device at a time, then the changes, for example, the time taken to perform network service changes could take weeks, okay, if not longer. And best case scenario, if you use network automation tools, okay, that are becoming more and more popular in the field of network engineering in the last decade or so, um, the changes, okay, the time taken to perform the network service changes could be as quick as minutes. Now I will briefly demonstrate how network engineers may leverage Python to aid in network automation. Here I have a Ubuntu box on CML. If I just log in here, so Ubuntu is a Linux distribution, okay. Um, and what I can do is I can directly activate a Python interpreter on the box itself, as I will do in a moment here. Um, the latest Python is 3. Okay, so there we are. We have now activated the Python interpreter. First thing I'm going to do is I'm going to import the module called IP address. Now this module is commonly used. It helps with IPv4 and IPv6 addresses. Okay, and in this brief scenario, I will be trying to find out using Python the number of usable addresses in a particular subnet. Okay, so when I say usable addresses, what I'm referring to is the range of addresses that can be assigned to hosts. That does not include the network or the broadcast address. Okay, so if I firstly just import that module, okay, we can even see the available options we have in this particular module. As you can see, we have all of these different things that we can use depending on what we are trying to achieve, whether it's the interface, whether it's the network address, whether it's IPv4 or IPv6. So in this particular scenario, let's call our network, let's call it Trek network. Okay, this is our variable, and we assign it a value. Okay, so IP address, this is the module we're using, and we are looking in particular to find out the usable addresses in a particular network. Okay, so we have to give the network address. Okay, the network address being the first address before the start of the range that is actually usable for the hosts. Okay, so the network address, it identifies the network. So let's say for instance our network was 192.168.30.0 with a mask of /28. Okay, so we will be leveraging Python to find out exactly what the usable addresses are. Okay, so quite simply put, we will just use a for loop, which quite simply put is for loops are code that runs repeatedly for a defined number of times. So in this scenario, it will run until it prints all of the usable addresses in our subnet. Okay, so if I do that now, okay, so we're looking for the values in our network. So what I mean by our network is this variable here, TrekNet. We're looking for the values here. So in this scenario, it is the addresses, or it is in relation to this network address. Okay, so in particular, we're looking for the hosts that are available in this scenario. Okay, so if we, I'm not sure what's gone wrong here. If I do that again, for x in this, the name of the variable is TrekNet. Okay, and then hosts. Oh, how could I forget the colon? Okay, this is needed. This colon is very important for loops. Okay, so now I can actually define what needs to be done for x in here. So that will be print x. So all I wanted to simply do is to print all of the values, i.e. all the hosts in this particular network. Okay, so let's see what happens. There we have it. Notice how it does not include 30.0 because that is the network address, and it also misses out 30.15 because 30.15 represents the broadcast address. Okay, so this can easily be implemented into a Python script so that we already have the usable addresses ready and included into our Python script without even thinking about it. We can even try it again for a different subnet just to see. So if I go for example, let's say the 10.0.30.0 network with a mask of 29 this time. So let's try to reduce the pool of hosts. Okay, so if I do the loop again, okay, so I'm looking for the hosts in particular, i.e. the usable addresses. Okay, so can you print x again? So that it should give me this time the range from 10.0.30.1 to 10.0.30.6. Okay, there we have it. Okay, so this makes life easier and it makes the process of network automation possible. Python scripting is just one tool of network automation.